Welcome back, guys, to my channel, Sarthi Foundation. This channel is basically, and this foundation is basically work for child education and skill development. So there are a lot of programs going on in this channel for skill development, not only DevOps thing, but the big data, machine learning. We are a part of a Skill India program, so we are trying to, you know, teach or skill up the India, skill up the many people, not only one people but many families to live a good life, because skill is a new oil, right? Like a data is a new oil, the skill is a new oil. So you have to have a minimum two skills to for a successful career. So recently, if you see my videos, I always try to help people to crack the interview, because interviews are very critical in nature nowadays. Because this is the first point to get into any company, to show your experience and to work on some of the technologies. So today, what we are going to cover is the typical interview question regarding the Kubernetes and containerization. Why we need containerization first of all, and how to migrate any application. Guys, containers are there because we want to migrate the applications, and existing applications migration is a big challenge, because containers are just a new baby, but the applications are there from like 25 35 years ago. So most of the applications are Java based application, because JavaScript applications are 90% of application on the planet are Java based. So in today's agenda, what we are going to discuss is understand the application migration. We have a many Java based application. By the way, you don't need to be a application developer or something, but having a knowledge, guys, you don't need to be expert in that. But my only suggestion and recommendation would be that learn those things. No need to be expert, no need to write the code, but if somebody is asking you to please help me in migration on how to do the migration, so that you can at least you should be able to tell one story from your side. Okay, that we have a small application, we have one, like 1 year back we worked on some application migration and those things. So having a knowledge is always good. Whether it's you are from a cloud side, cloud engineer, but having a knowledge of DevOps is always good. God knows, I mean, if you get good offer from DevOps thing, then it would be right, it will be a wise decision to learn DevOps, right? In DevOps, mainly the challenges comes when we talk about the coding, because many people, they don't know coding. They are completely new to DevOps, and we help every month many people to crack the interviews for DevOps and cloud engineer. So if you want to help, any help in the the crash course and interview cracking help, then please let me know. Or if you are looking for any job search help or getting a job, so also let me know. You can contact me. But guys, one thing I want to tell you, nothing is free. Regarding the crash course, we are preparing this crash course by including some of the toughest project that will give you enough confidence, guys. Though don't think in that way that only 3,000 rupees में क्या होता है, 10,000 rupees बहुत महंगा है. Guys, I'm telling you, if when you get an offer of 15 lakhs, you will not consider this 10,000 rupees, and you will definitely go for more expensive courses, because if you want to retain your 15 lakh package, you need to do that. That's a that's a critical thing, is nobody will help you when issue comes and when you get flooded with the tickets, right? So you need someone, or you need some team, or you need your own knowledge, your skills, your experience, or your confidence to close those tickets. So don't think into that way, that okay, I want to save some money, I'll go and see the YouTube videos and crack the interview. You may, I mean, it's not something that many people don't need anything and to crack the interview. Many people can crack the interview, but when we say we need uh, interview help, it means that 70% people, the normal percentage of people need interview cracking help. So if you consider yourself in those 75 to 80%, or you consider yourself in that remaining 20% who can, go to the IIT exam and, without preparation, and, come out with the flying colors. So it's up to you whether you want to, consider yourself, or you are a special guy. Anyway, so let's start. Understand the application migration. Then we will see how we migrate a Java application to AWS ECS. The same procedure for AWS EKS also, and understand the steps required for a migration. How to migrate a Java application step by step. See the understand the architecture. The first of all, we need to understand the application architecture, importance of the prerequisite, importance of the each steps, deployment overview, and what to watch out for the near future. I mean, this is something that any application developer will tell you about that. Now let's see the application migration to AWS ECS. We have some on-prem application. When you somebody asks you in the interview, you need to tell that we had some. I mean, I was working in a project where we had some on-prem applications. Monolithic, but those are monolithic means those are not in the cloud, or not in the Kubernetes, not in the microservices type system. They call it the monolithic. So dependencies are well defined in that thing, and it's a big one script or one big application, right? So we need to check out the possibility of getting into AWS. So the when you say we are trying to migrate, so we need to check the possibility whether it's possible or not. So we might need to modify some application code during this process. You need to tell them in that way that we modified some codes in the application to migrate the application to the to the AWS. The same thing applies for Azure also. So if you are looking for the Azure side also, so monolithic apps are difficult to manage in the cloud. So they will ask you, what do you mean by monolithic? So monolithic apps are difficult to manage in the cloud. Challenges to manage the dependencies, difficult to troubleshoot, and we need to keep app specific expert to manage the ghost code. Means the application codes are very complex. So one guy who knows the Java in and out, he should be there. If he left the company, then it will be problematic to manage the application. So that's how the challenges are there. And then here the typical solution that, okay, let's move it to the AWS with the microservices. So what do you mean by microservices? How do you manage those application microservices? We'll see that. So what are the steps for migration? To understand the application architecture is the first thing. If somebody asks you in the interview, tell them that um, the first step is to understand the migration, understand the application architecture, and then define the prerequisite. What are the prerequisites are there? And move existing Java Spring monolithic application to ECS first. We are not breaking the application into the microservices. Before that, we need to move it to the ECS, and then convert the monolithic application to the ECS thing, and then test the applications. So any application which is three-tier application, it's a Java-based application. Which is if it is a three-tier application, you can tell them that this is a typical three-tier Java app where we have um, APIs, multiple 7 to 5 APIs. They are pointing to the different pages or different views. So HTTP, this is typical architecture. This is a three-tier architecture of the Java app. So define a prerequisite. So what you need to define as a prerequisite. So you need to have AWS account and access key, CLI installed, Java, Maven, Python, Docker. These are the things that you need to have in place before you migrate the application. So you move monolithic application to ECS first without modifying the code. So that's how we, if you see this code with this process, we have this monolithic application here. this application, and then we have a load balancer here, the port numbers and the application target group. We create the application target group, and application target group will have we need to mention the ports over there. But remember one thing, we are not breaking the application. It just as is. We are moving that code to the ECS thing. So when you move that code to the ECS, and you want to see that whether the application is running or not, that's we need to check it out on ECS. And why we break the application, because to manage the application in a better way. We don't want monolithic application. Even we can run monolithic application in cloud, but in the cloud we have other services, advanced services also there, that will help the application to work better, to run in better way. So monolithic, once you move the application to monolithic, it's a here it's a load balancers, and the load balancer round robin drifting, distributing the requests to the different application target group. And here we have each container has single application process, which is handled to the specific port. Remember guys, this is a specific ports. Even though the normal port is port 8080 or port 80, but application talks on a port basis. Port basis means the application component will talk to each other on the port basis. So this is the first step that you will be taking. The first step, the somebody asks you in an interview that first in an initial days is a prerequisite. If it is a Java based application, then Maven, Python, Docker, they need to be installed on the EC2 instances on ECS, and then move the application to ECS thing. The first thing is to move the application to the ECS. Now the real recipe comes when the client application that makes a request to the load balancer. How it works basically, once you move the application, the monolithic application, not a break the application in the form of microservices. Forget about microservices now. We are moving application from on-prem to ECS. And what are the steps? First is the client application that makes a request to the load balancer. So client applications makes a request to the load balancer. So load balancer then distribute the request across all available ports and instances registered in the application's target group using the round robin fashion. Whosoever is like available or healthy thing, the target group that is updated by the Amazon ECS is always have an up to date list of all the service containers in the cluster. So this includes the port on which they are accessible. So obviously, once you move those application, definitely you will be moving that application on any of the EC2 instance, right? On any of the EC2 instance means there are many EC2 instance in your cluster. Inside that cluster, EC2, so we have Docker cluster, Docker containers. The Docker container program is running on all the EC2 instances on which you are going to move that application. Right now, the application codes are not broken. By the way, this is just an application is running on ECS cluster. So on ECS cluster, that hosts the container for the application, a VPC network to host the application ECS cluster and the associated security group. So here we are. If you look at this diagram, this box, so entire application is as a one part. There is no separate Docker containers or Docker images for that. So they are not loosely coupled. That's what the you need to explain them when you attend the interview, guys. The application components, when they are tightly coupled, it is not possible to move the application or change anything in that application. Or it's a risk thing is that if one component goes down, it will get another components also bring down, because they are tightly coupled. Means you are coupled with, let's say, five guys are tightly coupled, they are connected with each other. The one guy get down on the hill, then he will pull all other guys in the from the hill. I mean, from the cliffside. So that's dangerous thing. That's why here this is tightly coupled, still in the tightly coupled. Even though this is in cluster, even though this is in a cloud, but still it is tightly coupled. So the next step will be how to break it and make it in the loosely coupled. So these components, maybe these components will connect to each other, or different components connect to each other, but they are not tightly coupled. If something goes wrong to this one, the first component, it should not affect the other component, and that's what we call as a loosely coupled. The following is a, also a part of a solution that may not depicted in the above program. So Amazon ECS container repository for the application, a service task definition that spin up the container, the application container on the instance of the ECS, and MySQL RDS instance that hosts the application schema, the information about the MySQL RDS. So these are the application. When applications are there, database should be there. Application backend is a database, so you can bring those applications and database normally database, people not get into the container side, right? So you can tell in that way that applications are okay, but the backend, the database, still on the SQL thing. Now, when we need Maven plugin to push the images to the ECR, this was something we need to have those plugins, Maven plugins, to move the Maven plugins are required for Java based application. So Docker Maven plugin, these are very important plugins. Use the Spotify Docker Maven plugin to create the image and push it directly to the ECR. There are two ways to move the application to the cloud, guys. As you know, if you have attended any cloud engineering cloud admin program, one is the Elastic Beanstalk. Over there also you can manage through Docker, and the other way is to migrate through microservices. Or this is the typical way uh, to get your application to the cloud. So when we convert any monolithic or monolith application to microservices, what we do, what exactly we do, it's not something that only the Docker file will play everything. You know, in the Docker file, you can migrate or you can move some application from one place to another. But that's not the whole story. That's not the something we want to achieve. We want to achieve the microservices level. Means you once you move the application should be act like many microservices are running that application. Means every component will be a separate component and will work as a service. And that's what the ultimate intention. And if you see here the Java, the code in Eclipse, you can see here, this is the left hand side, this is the original code where um, you see the code on the left hand side when you open the Eclipse code. So these are all tightly coupled. Means if you see the code which are here, or these things, these are tightly coupled. Means these are part of one code, one big code. But on the right hand side, when you break the code, there's something we need to do on an Eclipse, guys, and then we can save this code, and then we can based on the code we will create um, the Docker file. And then here these every part and this is the one part, and this is the second part, third and fourth and fifth. These are all separate part. These are not, by the way, is one code. They are all, the dependencies are there, but they are separate. And that's what the we want to achieve in the microservices means the small code, small portion of your code will work as a service. And the benefit of that, if the one service failed, it will not bring down the other services, even though dependencies are there. But if some one service is there or stop, then other services will not stop. They will be running, and then eventually we need to repair that particular stop service, and then again it will run. So different components. So below you can see we are calling a pet API operation and not a pet repository. So this is what the code loose company means. If you see the code, I mean, by the way, when you get into if you join the course, then we will explain you how do you explain during the interviews. Sometimes they will give the code and they will say, show us how do you, what do you mean by do's coupling. So here on the left hand side you can see the old code, and then here on the right hand side when you see the code that we will the pet API operation, they are dependent on the repository. One operation, when the API calls are totally dependent on something. Let's say you are calling the API and that API call is dependent on one particular repository, and in the microservices that API call is not dependent or not completely dependent on pet repository. So we are adding one more layer in that. So 1 plus 2 plus 3, instead of that 1 plus 2 plus x plus 3. So if something happens to the 3, it will not affect the 2, and something affect the 2, it will not affect the 1. So this is in programming term we will explain you when you join the class, but this is something you need to explain in the interview side. And then now these things are a bit changed. If you see this change, so every component of the code, maybe this part of the code or this part of the application is 8080, this is again this 881 82 83. So these are all separate now. Earlier, if you go back to the old slide, everything is inside the one big container, but now it's a separate small container, the images, and then they make the container. So this is how the loose coupling works, and this is how we deploy the application. So obviously when you change the code, you need to change the docker file also. So docker file will bring the create the image, and then image from image you will deploy the application into the ECR. So that's it, guys. I don't want to take too much time. And if you have any questions, first of all, please subscribe to this channel. Here we will find a lot of things related to your AWS DevOps or Azure DevOps interviews or cloud engineer interview, mainly the uh, interview cracking and skill development. Interview is one part, guys. In preparing an interview is always good, but don't learn to crack the interviews. You learn to build your skills, and in that way your interviews will come. And then okay, because, people are only focused on just want to learn something for interview. Maybe you can crack the interview, but after that, when you start working here, you need to get the working knowledge. The projects are the real world projects, and that will help you to bring or to build your expertise areas. Till then, happy learning, and we'll catch you in the new video for DevOps or big data. Thank you, guys, and still then, happy learning.